So our first example at the top of the page is really just introducing us to what we'll be doing in this section. We're given two shapes, and they are named. We have triangle ABC, and these are the points we have. And then if you notice, we have a second one. It's also called ABC, but you see those apostrophes? In upper maths, when you see that apostrophe next to a letter, it means ABC prime. What it means is we took the original triangle and we moved it. We did things to it. So we're going to graph both, and then we're going to describe how we went from the first triangle to the second. This is why you have two colors, because it will be easier to see both of them, because they do overlap a little bit if you have two colors. So we're going to start with -2, 2. First, let's label our x and y axis. Which of these is the x-axis? Going left and right, perfect. And then which is the y-axis? Up and down. You're like, why are we still reviewing this? Because my first hour struggled, so we're just making sure you don't. Every coordinate point is an x and a y. So we want to go -2. From the origin, am I going to go left or right? To the left 2, and then +2 means we're going to go up 2. So from the origin to left 1, 2, and then up 1, 2. And then plot the point, make sure you label A. Because remember, we're going to have two triangles, and it gets to be a hot mess if you haven't labeled them. So we've got A. B is -4, -2. So am I going to go left or right? Left, and then -2, I'm going to go down. So from the origin, -1, 2, 3, 4. And then down 1, 2. And again, name it B. Can you see my yellowish color? We're okay with it? And then C, we got -1, -1. So again, left and then down. To the left 1, down 1. Some of you have rulers on your desk. If you don't, I'm going to pass out rulers. You'll connect the dots, and then you want to highlight it with one color. You have two on your desk. Lonnie, can you hand one to him? All right, and then for the second, we got -2, 0. So the left 2 and then up 0. So left 2, up 0. Make sure you name it A prime. That's an A and an apostrophe. A prime. We got -4, -4. To the left 4, down 4. So 1, 2, 3, 4. Down 1, 2, 3, 4. B prime. And then C prime is -1, -3. So to the left 1, down 3. So to the left 1, down 1, 2, 3. Connect those dots and then highlight it in a second color as well. Are we okay with our two triangles? So we're going to describe two things that happened. We're going to describe the horizontal shift, which should be a word you remember from Algebra 1. And then there's going to be a vertical shift. So we're going to talk about both. So you're going to compare A turned into A prime. So did I have to shift left, right, or neither to get from A to A prime? Neither. So we're going to say it shifted 0. And then the vertical shift, did I go up or down? Down 2. So what does that look like? I went down 2, looks like a -2, right? So I'm literally going to teach you this lesson here in two parts. There's going to be what we call writing a rule, and then there's going to be writing it in vector form. I'll show you both here, right now. So we're going to learn to write a rule, and then we're going to write in vector form. And then we'll go in depth into both of them here in a second. So if it says write a rule, every coordinate, x, y, transformed or translated some way. So writing a rule looks like this. You write x, y in parentheses first. And then you tell me what happened to the x and what happened to the y. So with x, what did I do? Literally nothing. So I don't put anything. I don't put plus 0. I don't put minus 0. I just put x. X stayed x, right? I didn't do anything with that. But with my y, what happened to my y's? I subtracted 2. I went down 2. So writing it like a rule, writing it like a rule looks like this. You tell me what happened to every x and y. The x, nothing happened, but the y, we subtracted 2. That's writing a rule. Vector form looks like this. Are you ready? This one's even easier. Draw like a less than and then a greater than. So these are kind of like parentheses, like a coordinate point. And then you write your horizontal component. So did I go left, right, or neither? Neither. I went 0. And then you write your vertical component. Did I go up or down? I went down 2, right? So negative 2. Those are the things we're doing today. That's it. We're going to go in depth into both of them. So if it doesn't make sense to you right now, that is fine. But we're going to be graphing 2 pictures and then describing what happened to them via a rule or via a vector form. We're going to start with a rule. Okay? So before we even do that, this is called translations. 4.1 is about translations. So we're going to perform them and then also compositions. A composition is when you do more than one. So let's say you went up 1 over 3 and you drew that picture. And then you went down 4 over 5 and you drew another picture. That's a composition. It just means doing more than once. That's all. So a translation is a blank. It moves every point of a figure. So it moves every point of a figure the same distance in the same direction. So it moves every point of a figure the same distance in the same direction. So above our triangles were translated because they moved neither left or right, but they all went down 2. That's what translation means. So we got this picture. We're going to change what we're going to do with this picture. We're going to write a rule for any coordinate. So go ahead and highlight the phrase, write a rule, to the directions of part A. The rest of it is just like mumbo jumbo we don't necessarily need. So we're going to, again, learn to write a rule. And the rule will look like this. Go ahead and start writing that below. So a rule says we're going to take x and y and do this to every single x and y coordinate. So with the x, we're going to add or subtract a number. And the y, we're going to add or subtract the same number. That's all writing a rule is. We kind of practice it above. So in my first class of the day, they kept skipping this part. This part says we take the original coordinates and we do things to all of them. So make sure you put this. It is part of the rule. So we're going to use a rule and we're going to graph. Your directions don't have this. Go ahead and write this down. We're going to go 4 units to the left and 3 units down. 4 units to the left and 3 units down. Four units to the left, 3 units down. So let's talk about the x coordinate first, right? The x-axis goes left to right, right? So if we go left on the x-axis, is that positive or negative? Negative. And if we go right, is that positive or negative? Positive. So that's your x. If you see left, you're going to go negative. If you see right, you're going to go positive. And then for y, what direction do we go for a negative y? down, and then what direction do we go for a positive y? Up. So those are the keywords you're looking for. So we're going to write the rule, and then we're also going to graph it on our picture. So remember, a rule looks like this. You got x, y coordinate, and then x, something happens to the x's. So which of these pertains to the x's? 4 units left or 3 units down? 4 units left. So am I going to go plus 4 or minus 4? Minus, because on the x-axis, minus is to the left. And then 3 units up means I'm going to go plus or minus? Oh, sorry, it says down. Sorry, 3 units down means we're going to go plus or minus? Minus, might be, guys. So that's the rule. All right, we're going to graph the rule. I think it's easier just to reread this. It says 4 units to the left and then 3 units down. So we'll start with A. We want to go from A, 4 units to the left and then 3 units down. So you're going to count 4 to the left, 1, 2, 3, 4, and then 3 units down, 1, 2, 3. 4 units to the left, and then 3 units down. So we're going to call that A prime. Same thing with B, 4 units to the left, 1, 2, 3, 4, 3 units down, 1, 2, 3. B prime. And then C is 4 units to the left, 1, 2, 3, 4, 3 units down, 1, 2, 3. C prime. And then connect your dots. Beautiful, isn't it? We feel okay about it? Okay, move on to the next page. We're going to talk about vectors. Vectors. So a vector is a quantity that has both direction and size. The textbook's like magnitude, and I just thought it was too extra. So it has both direction and size. And it is represented in the coordinate plane by an arrow drawn from one point to another. By an arrow from one point to another. A vector is a quantity that has both direction and size, and is represented in the coordinate plane by an arrow from one point to another. What does this look like similarly in geometry? It looks like something. A what? Array. It looks like a ray. Guess what? You name it very similar to a ray. A ray, you had an arrow pointing to the right? And then what was the first letter we always used? The beginning point, right? The start point. And then the other point was just listed second. A vector is very similar. Are you ready? Here's all it changes. That's what the symbol looks like. It's like half of an arrow. I don't know how else to explain it. You don't draw the other. I don't know. It looks like a crochet hook, if you've ever crocheted. I don't know. Or Maui's? No, Maui's is too. But anyways, it's the same idea. So you're going to draw this arrow. Whoop, I started erasing it. That's not what I was trying to do. You're going to draw the arrow type thing, and then you write your starting point first, and then the second point later. So what is my starting point of this vector? P. And then Q is the second. So that's how you name it. I believe there's a blank that says naming. Name the vector. So you have like your little half arrow. Does a half arrow make sense? Like how else would you say it? I mean, yeah, it's weird. Oh, a weird check mark. You're right. That's fine too. And then to write a vector, here's what happens. You have your initial point, and then your terminal point. We already said that. And then you're going to write the vector like this. You have two brackets. And then you write the horizontal shift first, and your vertical shift second. So horizontal shift, and then your vertical shift. It's easy to remember which order because it's X and Y, right? Which axis is horizontal? The X, and then the Y is the vertical axis. And then again, remember that if you shift to the left, is that going to be a positive or a negative X? Negative, and then if you shift right, it's positive. And then if you shift up, that would be positive. And then if you shift down, that is negative. So keep that in mind. So in this picture, we're going to go from P to Q. So you have like a box on your picture. It's because we're going to talk about the horizontal shift. So how much do we have to shift horizontally? 5 units. So 5 to the right. So 5 to the right, it's going to be a positive 5. And then to get from P to Q, we go up, right? How many do we go up? Yeah. Up 3, 3 up. So is it positive or negative? Positive. So that is the vector. That's the name of the vector. 5, 3. We went to the right 5 and up 3. Make sure you have these like less than, greater than symbols so that it doesn't look like a coordinate point because it's not necessarily a coordinate point. All right, how do we feel about vectors? Good. We're going to practice. You got one at the bottom of your page, right? So we're going to name it and then write the component. Starting with the name, again, it's like that half arrow, the weird-looking check mark, however you want to look at it. Which letter would come first in this picture? P. Good. And then Q would be second. So that's the name. Name it. Done. It says write its component, or write in the component form. So to get from P to Q, we want to do horizontal first. Do we go left or right? We go left. 1, 2, 3, 4. So if I go to the left 4, is it positive 4 or negative 4? Negative. I went to the left. So negative 4. And then I go up how many? 1, 2, 3, 4, 5. So it'd be plus 5. Negative 4, 5. Are we okay with it? All right, you're going to go to your whiteboard real quick. We're going to go back to the notes, so don't put the notes away. We're not done with them completely. But name the vector and write its component form. Name the vector and write its component form. Sorry, in your whiteboard. I would do them one at a time because it's a lot for me to read. I'm just letting you know. So I would answer all the first part and then move on to the second part. Good. Yes. Good. Yes. No, the second one's first and second are good. most of you answered the first one, so I'm going to go ahead and answer on the recording. So named MN over 1, 2, 3, 4. That's to the right, so it's positive. Then up 1, 2, 3, 4, 5, 6. Also positive because they went up. Good. And also good. Good. The third one, watch how you named it. That's good. This next one, where did we start? B towards A. And then did I go left or right? Left, 1, 2, 3, 4, 5. So it's negative 5. And then I went down 1, which is negative 1. And then last, the naming, it's not necessarily tricky. What's the starting point here? K, and then J. Did I go left or right? Left, 1, 2, 3, 4, 5. And then did I go up or down? Up, 1, 2, 3. So positive 3. Questions on any of these? Good? Okay. Now we're going to use it to graph. So go ahead and erase your board, go back to the notes. So I'm going to teach you 2 ways to do this. But before we even begin, we're going to graph our first triangle. So we're going to go ahead and graph those points, A, B, and C. So we got 0, 3. So over 0, up 1, 2, 3. Yes, we're on the next page. Over 0, up 1, 2, 3. And then 2, 4. So over 2, up 1, 2, 3, 4. And then 1, 0, over 1, up 0. Connect the dots. All right, we have ABC done. Okay, so we can do this one of 2 ways. You can take the originals. So we had A was 0, 3, B was 2, 4, and C was 1, 0. And what you can do, the vector is negative 1, negative 2. So what you can do is apply that to each point, subtracting 1 to the x and subtracting 2 to the y. And that will give you your new coordinates. So I'll show you what that looks like. A prime, what's 0 minus 1? Negative 1. And then 3 minus 2 is 1. So my new coordinate point would be negative 1, positive 1. Everyone see it? This is option 1. I'll show you option 2 when we're done with this one. Same thing with B prime. 2 minus 1 is 1. 4 minus 2 is 2. Can't tell if we're okay with this or if we think it's easy. 1 minus 1 is 0, and then 0 minus 2, negative 2. So we're going to plot all of those. We got over 1, up 1, 2 for B prime, and then over 0, down 2 for C prime. So again, connect your dots. I would color them 2 separate colors so that you can see them. So that's option 1. You can write it out. Sometimes I may not even ask you to graph it. Just tell me what the new points are or something like that. Here's option 2. If your vector is negative 1, negative 2, what did I do to go negative 1? What direction? I went to the left 1, and then for negative 2, I went down 2. So look at A and compare it to A prime. Did we go to the left 1 and down 1, 2? Yes. So you could also just look at it that way as well. However you want to do it is one of those 2 ways would be correct. But either way, question on either method. So left 1, down 2. Okay. All right, so now we just talk about some words. Okay, a transformation is a blank. This whole chapter is about transformations. We're not necessarily going to do all of them. But But a transformation is a function that moves or changes a figure in some way to produce a new image called image. So it is a function that moves or changes a figure. So it moves or changes a figure in some way to produce a new figure called an image. So there are 3 basic transformations. You've heard of them before. Each section, 4.1, 4.2, 4.3 are about them. This first one was a translation, right? We called it a translation. So 4.1 is a translation. Go ahead and write that, translation. Did the shapes look different when we moved them? No. We translated them. We moved every single thing in the same way, so they were congruent. Reflections, you should have heard of before. All right, so we get translations. 4.2 is reflections. And then 4.3 is rotations. All 3 of these keep the shape, like the integrity of the shape, the same. They'll all be triangles. But translation, we shifted it left, right, up, down. What do you think you do for a reflection? You flip it. Yeah, usually you reflect it about some sort of line. And then a rotation, you'll rotate it. But either way, the shape stays the same. Length, width, and all that stuff, it just moves. So that's what we're doing in these first 3 sections. But there are some words we need to learn. So below this, it says the original image, it is called a pre-image. So that's your first blank. So the original image is called the pre-image. The original is called a pre-image. So in this picture, here's my pre-image. It's SR. How did I know it's SR other than the fact that I just told you the pre-image was SR? A solid line, yes, was the main reason. It doesn't have any of the apostrophes, right? So if you notice, R has 2 apostrophes. 2 apostrophes versus 1 means nothing. It's still R prime. But this R would be the original, and S would be the original. So those are the pre-image. That's the original segment. All right, and then the second thing, the pre-image has inputs. So that's your second blank. The pre-image, those points are called inputs. So the pre-image has inputs, and then the new image is called an image, and those are outputs. So the pre-image has inputs. The new image we just call an image, and it has outputs. Okay, those points are called outputs. All right, so what are the inputs? So what are the original points? Right, -6, 8. So put S, -6, 8. That is one of them. And then R is the other. It's -8, 5. Those are the inputs. Those are the originals. And then your outputs are the new ones. So S turned into S prime, which was -3, 6. R turned into R prime, which was -5, 3. Then it says write a rule. So writing a rule looks like this part first. So every X and Y coordinate, something happened to each of them. So I would just pick S or R, one or the other. Which one do we want to figure out what happened? S, sounds good. So we're going to compare the S's together. So the X is the horizontal component, right? So from S to S prime, do we go left or right? We went to the right how many? We went to the right 3. So is that positive or negative? Positive, because we went to the right. And then our our vertical component, which is the second, vertical. Did I go up or down? Down, and I went down how many? 2. So if I go down 2, is that plus or minus? Minus. Now I want you to take a second and look at what we just said. Did the X's go plus 3 to go from the previous to the pre-image to the real image. Did minus 6 plus 3 make minus 3? Yes. Did 8 minus 2 make 6? Yes. So that's kind of what we're saying what happened. Negative 8 plus 3 makes negative 5. So just so you know what happened here. Are we okay with the rule? Okay. Perfect. Ready. We're going to write a rule. Then we practice, and then we do one more thing. Write a rule from triangle ABC to triangle ABC prime. So remember, every x and y coordinate, something happened to them. So we want to pick a letter ABC. A, okay. Is the red or the blue the original? The blue. So A is the image, the pre-image, sorry, and then A prime is the image. So when we say X, did we go left or right? We went to the left. How many?
4.
We went to the left 4, so that would be negative 4, correct? So the left 4, and then we went up 1, so it's positive 1. So that's our rule. What is it? So if you want to kind of connect all the pieces, why did we learn about vectors? It's because you use the concept of a vector right here. To go from A to A, what happened? We slid left 4 and then up 1. All right, you are going to practice on your whiteboards. Brady, you doing okay? Okay. You want to start on that? We're going to go back to notes for 1 second and then be done. The second one, I would count again. Yeah, just the second one. One of them I would just recount. That's good for the first one. Good. 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 I'll hand you these while you're waiting. We're still going to go back to the notes here in a second. All right, so I'm recording again, so just so you know. So P is the original, P prime is the newer image. So we went to the right 1, 2, 3, 4. That would be plus 4 because we went to the right. And then up 1, 2, 3 means we went plus 3 for our Y's. For the second, did we go to the left or to the right? To the right 1, which would be plus 1, and then we went 1, 2, 3 down. So is it plus or minus? Minus. Good. The last thing we're going to do is on page 5. Let's go ahead and go to page 5 really quick. we're going to use the translation to write the missing pre-image or image. So we're given one or the other. Remember, which one comes first? The pre-image. And then second would be the image. So what happens between the two of these? So how do I go from the pre-image to the image? Right. We go +6 and down 3. Yeah. So that's what that statement is saying. So we've got to figure out which one we have and which one we need. So in this first one, we have the image, right? Is that the first or the second? It's the second picture, right? So we need the pre-image. I'm just going to write pre. If we know the image is J prime, it's 10, 2. We're going to figure out what the pre-image had to be. It would be J, right? So they added 6 and they subtracted 3. So what did I have to add to 6 to get 10? 4. And what did I have to subtract from 3 to get 2? 5. So the original image was 4. The pre-image was 4, 5. If you want to think about it, if this direction we are adding 6 and subtracting 3, to go the opposite direction, you do the opposite. So if you want to think of it that way, 10 minus 6 gives you 4, and then 2 plus 3 gives you 5. I don't know if you want to think of it that way on that particular one. And then last, they gave you the pre-image, so we need the image, which would be R prime. So again, they added 6 and subtracted 3. Right? So if we added 6 to our x's, what's my new x? 12. And if they subtracted 3 for my y's, 8 minus 3 is -11. So that is the new image.